Autonomous cars are a big thing here at Hardware Pioneers 2022, and with me is
Loïc.
And in front of me is a small autonomous car that was made for is it the NXP Cup?
No, this one is not made for the NXP Cup,
right,
but the FMU on it is made, is included in the NXP Cup car.
Right, yes, of course, sorry,
the
yes.
FMU, the K66 V3,
yeah.
that's the same FMU as is sold as for the Cup car, yeah.
And so if I understand correctly, this thing will follow whoever wears this device?
Yeah,
show me, please.
it can follow me around, it just moves. I have the initiator in my hand here, and it follows this initiator around wherever I go. So this is using Ultra-Wideband technology.
Yep.
We have Ultra-Wideband on here, Ultra-Wideband on there,
yep.
and it's measuring the distance and also the angle of arrival on the device, and then just follow and tries to get close.
So tell me a little bit more about the hardware on this thing, because we're seeing lots of different boards here.
Oh yeah,
all of them
we have
flashing.
a lot of boards on there.
So please tell me.
So we have for once we have the SA150. That's the Ultra-Wideband chip that's on here.
Right.
It's also using it's connected to the Q9090 on here for the host communication with the Bluetooth and everything else to start communication between Ultra-Wideband.
Yep.
This board is made by Mobile Knowledge.
Yep.
Then we also have the FMU K66, of course, which I already told you that's part of the NXP Cup car, where we have a new FMU coming soon based on an RT-based chip. Then we have also the BMS. This is a battery management system to control the battery. Inside we have a 4S LiPo, and this BMS controls the charging and state of charge of these cells, and it also shows you a charge indicator with the green LED. Right now it's almost full, so it's blinking 4 times. Then we have on here NavQ and NavQ Plus. This one, the NavQ is using IMX8, and the NavQ Plus has an IMX8M Plus with also machine learning accelerator on it.
Machine learning?
Yeah.
Oh, brilliant.
The TensorFlow unit. So they enable all kinds of different companion computer applications. So you would have you can do offboard control with it using ROS, steer the rover just using the companion computer, do machine learning use cases, whatever you want. If you need a little bit more beef on your rover, or you want to have dedicated hardware for all kinds of programming stuff, that's for that. We also have under here, it's hard to see, that's the CAN Hub K3. It's a F32 K3 based chip, which does the CAN Hub communication on the board, so you can connect all kinds of CAN devices to this CAN Hub.
You're using CAN?
Yeah, we have on all our devices, on all the mobile robotics devices we are including CAN connectors. We have 2 on the FMU. And of course the CAN Hub, we have ones on the NavQ, on the BMS, and they are all interconnected with CAN and doing the inboard communication between the devices.
That is absolutely fascinating. So I suppose my question now is, if you're a maker and you want to get into something like this, where's the first place to start?
You can go to the NXP website and look for the Hovergames kit, and from there on you will probably be guided to the NXP Git book for all of these kinds of components. We have for every component we have a Git book where you can know we have a guided a detailed guide to all of the components, how to do it, how to program them, how to work with them, and where to buy them.
So my last question, I suppose, would be: if you're a maker, which one are you going to pick first of these modules? Which one would you go for?
Or it's either the NavQ or the FMU.
Well, there you go.
Yeah.
Thank you ever so much.
And of course, I have to say that Ultra-Wideband is the most important part, because I'm working mostly on Ultra-Wideband.
Fair enough.
But you need something to connect those also.
Yeah. Oh, fantastic. Well, thank you ever so much for taking the time to show us this unit.
No problem.
Thank you
I'm
very
having a lot
much.
of fun.
Absolutely. Thank you very much.